Okay, good afternoon, everyone. I'm Kubi from OpenHarmony Compliance SIG.
And I'm Alberto Pienon, the Eclipse Oniro Compliance Toolchain project lead.
Okay, today we are very pleased to share with you our practice about license compliance, especially our collaboration works. Our presentation will cover following 3 points. First of all, I will introduce OpenHarmony compliance practice and its challenge. Then Albert will introduce Oniro IP compliance toolchain practice and collaboration progress. So, as you may know, OpenHarmony is an open source operating system framework for smart device, and it is incubated by OpenAtom Foundation. OpenHarmony is designed with a layered architecture, which consists of kernel layer, system server layer, framework layer, and application layer from the bottom up. System functions are expanded by levels from the component to subsystem, further to system. In a multiple device deployment scenario, an unnecessary component can be excluded from the system as required. For the part above the system service layer, we primarily use Apache 2.0 license as main license. For kernel layer, as devices with different compatibility may use different kernel, so there are 2 types of license at the kernel layer, GPL 2.0 and BSD3. Similar to other OS, the OpenHarmony also has a large number of code and repositories. In OpenHarmony community, there are 110 million lines of code, more than 700 code repositories, more than 800,000 files, and more than 118 third-party open source software has been introduced. Due to the introduction of those third-party OSS, from the perspective of license management, the number of main license types we need to handle has reached 14.3. For file-level license, the number can reach up to 306. In order to address the compliance risk associated with a large number of license types and open source softwares, we have built an open source compliance architecture for OpenHarmony. As you know, compliance is indeed a complex task. The first thing is to adoption of the OpenChain standard. ISO 5230 is an international standard for license compliance, providing a framework for organizers to manage and ensure to license compliance. Based on this standard, we have developed compliance compatibility from various dimensions. This multi-dimensional approach ensures a comprehensive compliance strategy that covers all aspects of license compliance. Firstly, we focus on process documentation and specification. This includes establish a clear guideline and produced by contributors and auditors and others. Secondly, we build an IP compliant toolchain, particularly the part highlighted within the red circle. Those tools can help us efficiently manage license from the introduction stage to release stage. Lastly, we can consider the team. This means training and equipping the team with necessary knowledge and skill to handle the license compliance issue effectively. When we focus on license management and aim for efficient and accurate management of license. We realize that the key lies on accurate identification of license type, whether it's in the context of license admission scenario, license compatibility check, or fulfilling license obligations. This is crucial. However, efficiently and accurately identify license type remain a significant challenge, especially in OS community. We will face a great deal of complexity. From the perspective of the license text, we need the capability to handle the identification of license variant, recognize exception clauses, and identify multiple licenses in one file and their relationships. Furthermore, from the engineering perspective, we also need to address issues such as tools execution efficiency, handle false positive, and support for custom compliance rulers. So we develop tools named OSS Audit Tool, in short OAT. It is an automatic review tool for OpenHarmony. It can automatically scan the code based on custom rulers of license and copyright. Identify the code that does not comply with the rule, and generate a scan report. It provides highly customizable license matching rulers. If some license type cannot be recognized by default ruler of OAT, the repository committers can identify it manually and config these matching rules, so OAT can know everything. Also, it provides flexible issue filter and confirmation rules. So all the confirmation about the filter can be stored with the code in the repository. Moreover, it has already been integrated with the merge gate of OpenHarmony CI pipeline. So used to identify and check whether the license of the corresponding file is correct when a developer submits a pull request. However, maybe you have found out in this mode, the accuracy of the license type identification depends on the committer's capability of identifying abnormal or unknown license. Obviously, some of them cannot fully handle these issues. Although we have legal team and compliance sake, we still cannot ensure that all the license confirmed by committer is correct. Fortunately, the Oniro IP compliance team has done another fantastic thing, practice in license management. Therefore, by collaboration with Oniro IP compliance team, we can get an enhancement in license type identification capability. So I will hand over the stage to Albert to introduce Oniro's best practice.
Yeah, as was presented in this morning talks, Oniro is the OpenHarmony distribution for the Western market, and is a project hosted by the Eclipse Foundation in cooperation with the Open Atom Foundation, which is the incubator for the OpenHarmony project. The IP compliance work and the IP toolchain has been created by a collaboration between Array, a law firm I'm partner to, and the Neutech Park, which is a science and technology park based in northern Italy. And we also use as a starting point, as a reference, the OpenChain standard, that defines the main requirements that a compliance process must have when it comes to open source. We use the SPDX standard, which is a standard to declare the package license and copyright information on a file basis. We use the reuse standard, which is a standard promoted by Free Software Foundation Europe to identify in a machine-readable way the license for each source file in a specific component. We use some tools, mainly Fossology and ScanCode, that are two compliance tools that are fully open source, and I will tell something more about them in a minute. And then we also leverage the compliance work already done by the Debian project, which has a very comprehensive process to manage the license compliance of the components that are included in the distribution. The final result is collected in a dashboard where for a whole project we can get the license conclusions that our auditors made on specific components. And you may also, okay, this is the dashboard live. So you can get the general view, and then you can get the view for single components. You can filter by third-party components and get all the licenses that have been found in the distribution. And this is something we wanted to add on top of the Oniro project, in order to provide downstream adopters with a tool to identify the licenses of the components that are actually used in the distribution. And yeah, so this is a filtering and the license pie chart for each component. And then, okay, so starting from the beginning, which is the auditor's problem, the main problem, is the license detection. The first issue is that there is an incredible diversity of open source licenses. The OOSI website lists more than 120 approved open source licenses, but there are many more out there that are maybe open source, maybe not, maybe free licenses that do not meet the open source definition, but in any case need to be handled. Why? It's like it happens with standards. So in theory, we will live very well with 4, 5 licenses, maybe one more permissive, one copyleft, one weak copyleft. But the problem is that over time, every project wanted to have their own license and thinking that was a good thing, but the problem is that it became a real mess. And the problem is not just identify the license, because there are multiple variants for the same, even the more adopted ones. For instance, in our work, we did to export our findings in order to be reused in the OpenHarmony project by the OAT tool. We found, for example, more than 45 small variants of the MIT license text just in one single component. I can show you that as an example here. So this is the MIT license. I guess you're already familiar with that. And then we have all these small variants you see in red and green. Maybe there is authors instead of copyright holders, or I don't know, small addiction. There are typos somewhere. So, and the problem for a license scanner is that they cannot assess whether these small variations are not affecting the meaning, the legal meaning of the license. Sometimes a single word or single line can change the meaning of the license. Maybe a license can become a different license. And an example is this one. There is a license that appears to be a BSD 3-clause license. I guess you already know a BSD license. But for instance, this license has a small line at the end. You acknowledge that the software is not designed, licensed, or intended for use in the design, construction, operation, maintenance of any nuclear facility. Regardless of the purpose of this clause, the problem is that this is not BSD anymore. This is not an open source license anymore, because this restriction does not meet the open source definition, does not meet the Free Software Foundation requirements. And for instance, it is inbound incompatible with the GPL. So you think you have a BSD license, but just because of one small line, it's something completely different from a legal standpoint. And you cannot tell, an automated scanner cannot tell whether this line is relevant or not. You need an auditor that examines it and tells whether this is relevant or not. So also, there are many ways of indicating the license. Maybe you find the license text. Maybe you find some other text that maybe states, like in this case, use of this source is governed by a BSD style license found in the license file. And you understand this is not BSD, this is BSD-ish. But actually, if you look at the text, it's BSD, pure BSD. There is no, apart from owner instead of holder, but it's not different. So this is a finding that an auditor is supposed to review and say, oh, this is not BSD style, this is a BSD 2-clause license, and that's it. So this is just another examples. And then you have cases with dual licenses, multiple licenses, license exceptions. So it's a very complicated task. So in theory, we have a solution. The Free Software Foundation Europe promoted a standard that is becoming a de facto standard for open source software. It's called Reuse. It's based on the SPDX license tag identifiers. So basically, it's something like, I don't know if you're already familiar with that, but basically, you just need to put a simple machine-readable text at the top of your source file, and you're done. So this should be a license identifier that corresponds to the one in the list of the official standard. But in this way, you can have any automated scanner get the correct licenses. What's the problem with this? That its adoption is, of course, voluntary. And for large projects, like, for instance, the Linux kernel, 100% coverage is still not reached, regardless, even if I guess it's 5 or 7 years that are working to implement the reuse standard for the Linux kernel. So the most part of the software of there is not compliant with the standard. So we still have the problem of identifying the licenses. So we have an open source tool. It's a long-standing tool. It's almost 18 years old now. And it is called Fossology. What's the main goal of Fossology? You have many good license scanners out there. The best open source license scanner is called ScanCode. It's a very good project. But the problem with the automated scanners is they all generate a high number of false positives and false negatives because of the reasons we seen before. So how do I curate scanner findings? I need an auditor to review that. So Fossology was created precisely to this purpose. Basically, it has a job schedule to automatically run all the scanners that you like, you can choose. You can always also choose scan code. And then it has a web UI. I can show that an example here. That is, sorry, I have two. So in this example, you have a source file. This is taken from the OpenHarmony code base, and you can identify the findings of the different license scanners. You have colors here, so you can see these license texts that have been detected by one license scanner, and then this is the text that have been identified by the open source auditor through means of a bulk recognition rule. So in this way, you can go file by file, or may also process in bulk a whole directory, and to confirm or modify or correct the automated scanner results. And this is a time-consuming work. This cannot be put in a CI pipeline because there is the auditor work that take days or maybe weeks to review a component. In our case, we develop a decoupled CI pipeline that sends the code to the auditor, then the auditor does his work or her work, and then the results gets back to the developers, but it's like kind of a partially manual, partially automated process. And another thing about the auditor's work, maybe in some cases, the legal text that you find in the source code is the text of the license, and that's easy. Maybe it's a small variant of it, and it's more difficult because you need to identify the changes and see if they are relevant or not. Or maybe it's just a text saying this code is covered by license A without saying which version of license A. So you need to maybe do a little bit of research and understand which version, I don't know, the GPL or the BSD license is used. Or maybe this code is covered by the license for it in some other file. And you need to look on the other file. And then you may also find deceptive licenses, like this one. So if you are very tired in the night and you reviewed a lot of licenses and you look at this text and you look only, I don't know, at the first condition here, okay, this is BSD 3 clause. Okay, wait, not. This is something that the distribution use shall be used only with Texas Instrument incorporated with silicon products. Any other use is prohibited. So this is not an open source license. And if I go to the top, I see redistribution and use in binary form is permitted, provided, okay, binary form, not source code form. This is not an open source license. But the thing is that the meaning of this license can be understood only by an auditor. It's difficult, even using AI, to make a computer understand in a reliable way this kind of issues. So the issue that we faced is how to export this work in order to be reused in a tool like OAT that has been presented by Kubi before. Because OAT tool is a great tool focused on speed that can be put in a CI pipeline in a very efficient way, but it needs the legal text. So it can detect the legal text. So we thought about exporting all the findings by our auditors into a JSON file in order to be reused by the OAT tool and to enhance the license detection capabilities of the tool. So the problem is that the export format used by Fossology is SPDX, that is a standard, but it does not provide the exact legal text that has been found in the source code, because it just mandates to provide the license tag. Maybe the text is if it's a non-standard license, but you don't have the actual text finding. There is no standard way to put that. So we did a little bit of research, and we decided to use Fossology API, because Fossology has a very good API with which you can extract any sort of information you find on the web UI, including the text highlighting that I showed you before. We had some practical problems. So we needed a way to filter the text in order to ignore comment formatting and text wrapping. We have some scanners in Fossology that do not detect whole text, but single words. And now we needed to calculate the correct line range. We needed to decide how to handle dual license cases versus multiple licenses covering all the source file or only a portion of it. There are three completely different cases. In one case, you can choose between two licenses. In other case, you have multiple licenses covering the whole code. In the third case, you have multiple licenses cover different parts of the same source file. So we found some solutions. Basically, we asked also the auditors working on Fossology to add some bulk recognition rules in order to get the whole text finding to export. And the example, I already showed you that one, but I will show that again. So this is the human-readable version of a JSON file. And here you can see all the findings. And here we have MIT, very, very long list. Then, I don't know, we have some kind of non-standard license. Then we have an identifier for Apache 2 license. As you can see, there is not the whole Apache 2.0 license text. There is just a reference to it. And then we have MIT-style licenses. So we have licenses that are mostly as the MIT license with different provisions. And so the auditors decided to categorize as MIT style because they decided that the variations are not a big deal. So they are not introducing new conditions that may be, I don't know, incompatible with something else. So basically, this is where we are. So the collaboration is still ongoing, and we realized that it is providing value on both sides, because since we need to export the metadata in order to be reused by another tool, we were forced to review our findings, to double-check our findings, and in this way we found maybe some small inconsistencies. Maybe one auditor was using a rule, another auditor was using a slightly different rule, and so the metadata is not consistent. So we are sorting out everything, and this will improve not only the license detection capabilities of the OAT tool, but also the quality of our metadata. And now the OAT tool and Kubi managed to do some test in importing our license metadata, exporting from Fossology into the OAT tool license database. There are issues also here because there may be some text findings that are peculiar to a particular context. So maybe some findings need to be exported not in the general database of licensed text, but in specific configuration files for specific components. But it's working. So I think in this way we can leverage the audit work we did in Fossology and embody it in a tool that does the license scanning in a very quick way. Just to give you a comparison, to scan the whole code base of OpenHarmony 5.0, It took, I guess, 1 week with Fossology. It takes 2 or 3 days with scan code. It takes just 30 minutes with OAT. So that's the real difference. So you cannot put scan code or Fossology in a CI pipeline. You can put OAT in a CI pipeline. And in this way, we can merge the best from the both approaches. And so these are our contacts if you want to know more. And I don't know if there are any questions or doubts.
Thank you for the presentation. My question is, in terms of next steps, what are the biggest challenges you think you need to face?
On our side, I can tell it's on the auditor's part. They are reviewing all their past work in order to spot possible inconsistencies in corner cases that are not so corner because they are very frequent. So text variants or other strange cases, in order to have a consistent metadata across all components. And probably we will decide to develop a small tool to help this process in order to flag and to open issues and to fix all the results in Fossology so we can export all the metadata and they are ready to be imported by the OAT tool.
Yeah, from OpenHarmony side, I think the biggest challenge is we need to reconfigure all the missing, the wrong part detected by the OAT with this metadata. Mm-hmm. So another thing is we need to convert the data format from the metadata to our OAT DB format. So I think these two things is the next step.
Are you handling text in different languages, not just English language?
Okay, this is a good question. Actually, we have an English-speaking auditors team. Of course, we happen to find some licenses in Chinese, but we always found the translation. So, of course, since the two teams are collaborating with each other, if we find something in Chinese, we will, of course, collaborate to understand the meaning, because, of course, also the OpenHarmony and the Open Atom Foundation, they have their IP experts, so yes.
Actually, currently, OAT can identify the Chinese license, such like Mulan license.
Yeah, Mulan 1, yeah. Okay, I think we have, that's more 5 minutes ahead schedule. So thank you. And here's the contact if you want to keep in touch with us.
Thank you.
Thank you.